Okay, you are welcome to your Materium online class. This is GC Practical Chemistry. Titration, question number 1, 1991. The following material were provided for a titration experiment. Solution A containing 10.9 gram per dm cube of an acid H2Y. Solution B containing 1.0 mol per dm cube of sodium trioxocarbonate 4. Watch bottle containing distilled water, 250 cm cube of standard volumetric flask, 25 cm cube pipette. Then you are asked what will be the color of number 1, methyl orange in solution A, phenolphthalein in solution B. Then we are asked to outline a suitable procedure for preparing accurately 0.10 mol per dm cube of solution of sodium trioxocarbonate 4 using the materials provided. Then another thing is that we name 2 essential pieces of apparatus required for titration, which is not included in the one listed above. Then we state 5 measures taken during the titration experiment to ensure accurate results. Then apart from that, we still have E part. So E part says 22.5 cm of solution A neutralizes 25.0 cm cube of 0.1 mol per dm cube sodium trioxocarbonate 4. Then we have to calculate the concentration of solution A in mol per dm cube, the molar mass of the acid H2Y, and then another thing that we have to do is check equation for the reaction, then before you start answering the question. Okay. So let's answer the question one after the other. So let's go back to the question. The first question says, what will be the color of methyl orange? What will be the color of methyl orange in solution A? So the color is pink. The color is pink. A Roman figure 1 is pink. Roman figure 2, methyl orange in phenolphthalein in solution B. The answer is pink. The answer is pink. Then B part, outline the procedure suitable for preparing 0.1. So we are not preparing 1.0 mol per dm cube. We are preparing 0.1 mol per dm cube sodium hydroxide. So we have to just prepare that. So how do we do it? So this is already stated on the board. You have to compute the mass. Compute the mass of the sodium trioxocarbonate 4 in the solution. So this is the mass you are going to measure with your beam balance. So how do you get this mass? So you are given the mole to be 0.1 mol per dm cube. So which is the same thing as mole is 0.1. So mole is mass over molar mass. So 0.1 is equal to mass all over molar mass of Na2CO3 is 106 gram per mole. So all over 106. Now cross multiply. You are going to have M to be 0.1 times 106, which is 10.6 gram. So this is the mass you are going to measure. You will measure that mass, then you will now do something. You will take it to a 250 cm cube standard volumetric flask. After dissolving it in a beaker, then you will go and start mixing it, start dissolving it in 250 cm cube volumetric flask. Then after some level of agitation, then you are going to pour it into that 250 and cover it and shake it very well. Shake it very well. Then you transfer it into another volumetric flask. That volumetric flask should be 1 dm cube, standard volumetric flask. Then what are you going to do? You will rinse any residue or particles remaining inside the 250 cm cube volumetric flask we used earlier. You will rinse it and pour it again into that 1 dm cube. What are you going to do next? You will check it well for thorough mixing. And what have you just prepared? You have prepared 0.10 mole per dm cube sodium triazocarbonate 4. Now, let's go to another question. Question number option C. Let's look at option C. Option C says, name 2 essential pieces of apparatus required for titration which is not included in the list above. Okay, let's go back to that question and answer it. So you are required to use 50 cm cube of burette, conical flask, and 400 cm cube of beaker. So those are other things that you can use which is not listed in the question above. Now, this says what? This says state 5 measures that you have to take when doing the titration experiment, not to ensure your accurate result. Rinse the burette and pipette with the solution to be used in them. So if you want to use acid, for example now, for burette, you have to use that acid to rinse the burette. You have to use base. Use base in rinsing the pipette. So that's what you want. Rinse it with that solution you want to use in there. Now let's go to other precaution for your titration. Number 1. Number 2. Clamp the burette in a vertical position so as to avoid error due to parallax while taking burette reading. Then number 3, place the titration flask in a white tie. So you have to put a tie under your flask to avoid overshooting the end point, so that you will not have end point that will be, let me say, after you have poured excess acid, before you realize that the color has changed. So number 4, air bubbles must be removed from the burette and pipette to obtain accurate volume of solution. That is, you should not allow bubbles. Air should not be trapped within, so that you can obtain accurate volume. Then remove the funnel before taking your reading. Before you take the reading on the burette, you must remove the funnel. So because there are some drop from the funnel that can increase the volume of your acid in the burette. So let's go to E part. So let's look at E part so that we can answer question E. E says we should calculate the concentration of solution A in mole per dm cube. Okay, we have the concentration of A in mole per dm cube, so we have to use this formula. Since in the question we have our concentration of B in mole per dm cube. In that question, sorry, the concentration of B is 0.1, not 1.0, not 1.0 mole per dm cube. So it is 0.1 mole per dm cube. So that is the concentration. Then the volume is given to us. If we check E part, we see that the volume of the acid is 22.5. The volume of the base is 25.0. The mole of the base is 1, that is the number in front that they use in balancing it. Mole of B is also 1. So what are you going to do? Cross multiply and make C a subject of formula. So that is what we did here. And making C a subject of formula, we have this. Then you substitute those values or parameters. So we have all here, and that gives us the answer. Ca to be what? 0.1111 mole per dm cube. Then in order to calculate the last one, which is molar mass of acid, H2Y. How do we get that? The molar mass will be calculated as